Sample problem number 3 for internal force convection. So for number 3, we are given with, this is almost similar with what we have for problem number 2. We have a thin-walled circular tube of diameter 50 mm, and then the length is 6 meter. It is maintained at a uniform outer surface temperature of 100 degrees Celsius. And inside this tube flows water at a rate of 0.25 kilograms per second. The inlet temperature of the water is 15 degrees Celsius. And because of the heat exchange between the steam and then the water temperature has increased to 57 degrees Celsius. Now we are looking for the value of H. So what is the value of H? So these are our assumption. Negligible tube wall conduction resistance. This is a thin-walled circular tube, so conduction here is negligible. Incompressible liquid and negligible viscous dissipation. So there is no change in the density of the water as it changes its temperature. The properties are also constants to make our solution much easier and favorable to us. So the bulk mean temperature is inlet temperature plus outlet temperature divided by 2. So evaluate Cp at 36 degrees Celsius. So since we don't have 36 degrees Celsius, we interpolate it between 35 and 40. So looking for Cp by interpolation, this is actually almost 4178. That's why we have 4178. The heat exchange again is between the whatever is outside this wall and the water. So meaning the change of temperature of the water is because of the heat transfer because of convection. So rearranging this equation to solve for H, noting that our surface area here is equals to pi dl. So that's why we have this equation here. Rearranging to solve for H, our H can be solved in terms of these values. So the only one that we don't have yet is our delta Ln or the LMTD. Solving for the LMTD, substituting the values, so we have Ts minus T exit minus Ts minus T inlet divided by Ln of this delta T divided by this delta T. This is equals our LMTD is 61.633 degrees Celsius. LMTD should be between the surface temperature and any of the temperature of the inlet or outlet. It should not exceed, of course. So the average temperature in the pipe, in the tube rather, is 61.633 degrees Celsius. So our H now can be solved substituting for the LMTD. So we have 755.22 watts per meter squared Kelvin.